Hello and welcome to our webinar, Tips to Support Your Teaching of Cambridge IGCSE Core and Extended Mathematics with Nick Hamshaw. I'm Eliza Sinatra from Cambridge University Press, and I'll be hosting this webinar for our speaker, Nick Hamshaw. Thank you for joining us today.
Good morning.
Morning. Since graduating from Oxford in 1999, Nick has taught mathematics throughout his career in a mixture of state and independent schools in the UK. Although now a senior leader, Nick continues to teach mathematics regularly. Nick is an author of the first edition of the current Cambridge IGCSE Mathematics Core and Extending Coursebook. And I'm going to give our attendees a little time to join the webinar before we start. So those who joined, if you'd like to chat to one another and let us know which country you're coming from, please free to use the chat box. It would be great to hear from you. And while you're waiting, I'm going to launch a poll to find out about your main challenges in a classroom. It would be very interesting to see what answers we get. If we haven't included your main challenge, you can add this to the chat and see if your fellow attendees have similar challenges. So let me launch the poll. Okay, I think you can see it on your screens now. And I can see the first answers. Fantastic. Oh, and I can see that we have a very international audience as well, coming from India, Saudi Arabia, Kenya, and Indonesia, Italy, China, Palestine. Amazing. Ghana.
Wow.
Truly international. And I can see some first answers as well. So a lot of people, currently 58%, find time management the most common challenge, followed by teaching with, oh no, actually, it's changing really quickly. Supporting a differentiated classroom is the second challenge. Okay, let's give it a bit more time. So while we wait for more attendees to join us, let me explain how we're going to run this webinar. We're recording the webinar today to share with you afterwards. So don't worry if your internet drops out, just rejoin us when you can. If you're having trouble with your speakers, we suggest using headphones or checking that your speaker is muted. Your microphone will remain muted throughout the webinar. And if you have any technical issues or questions about our maths products, please can you put those in a chat box, and my lovely colleagues Tamsin Hart and Arif Khan will be on hand to help you. And if you have any questions for Nick, please put them into the Q&A box, and at the end of the webinar, our speaker will answer those. 7 days after the webinar, we'll send you an email thanking you for your attendance with a link to the webinar recording and information on where to find the webinar slides. Unfortunately, we cannot provide certificates. However, you can use this email as proof of your attendance. All right, so let's have a look at our poll results. I can see that 71% of attendees have participated. Let's give it just 2 more minutes and see if we can bring this number higher. Bring it up. Okay. Well, time management is still leading. And I can see that a lot of people think that supporting a differentiated classroom is a challenge. And helping students work without a calculator is also definitely a challenge. Okay, I'll give it 10 more seconds and I'll share the poll results with you. Okay. I'm sharing the results. So you can see time management is at 55%, teaching with technology at 31%, preparing students for assessment, 23%, helping students work with a calculator, 8%. Helping students work without a calculator, 30%. Supporting a differentiated classroom, 44%. Helping students to gain 21st century skills, 23%. Supporting English as a second language learners, 14%. And equally, student and personal well-being, 14%. Thank you very much for your input. I'll stop sharing the poll results now. And that's the end of our introduction. So just before handing over to Nick, I'm going to remind you that this is a recorded webinar and that you can ask, you can also ask your questions in our Q&A chat box. So let me now hand over to Nick.
Hello, good morning. Okay, well, welcome to sunny North London, the first sunshine that we've had in quite a while. So it's really lovely to see all of the international representatives here. Hopefully today will be something that will provoke some thought for you. My aim is not to provide masses of content, but instead to actually get you thinking a little bit about how you might approach some of the teaching and how you might use our resources that we've created around this. So as my first slide says, we're looking at navigating new syllabus requirements, and that's mainly about how the students actually need to engage with the material rather than actually the content itself. The three main takeaways that I'm hoping that we will get from today's webinar would be to understand a little bit more about why low stakes testing matters, why precise mathematical language matters, and how you can help students to deconstruct problems. Now, there's a lot of material in the new textbook that we've produced that will support a lot of this, and I'm going to make reference to some of those things along the way and some of the new features. But the main purpose of this is to look at how we love mathematics and how we deliver the teaching of it. Now, of course, the syllabus does feel slightly different at the moment. And one of the reasons for it is that there has been some change to content. There's been a little bit added, all in the extended syllabus. You'll see that surds now have moved into number. Exact trigonometric values are now part of the syllabus. We did previously reference them in the textbook as an exercise, but it's now a much more significant part of it. Domain and range in functions, which will include composite functions, is in extended only, and now we've got square roots in the list of values for functions in the form ax to the n when we're sketching them. So that's an important part of the syllabus change. To subtract from this, note I'm using proper mathematical language quite deliberately here. There are some bits and pieces that are taken mainly out of the core, but there's some from the extended as well. Adding and subtracting vectors, for example, has come out of the core only. What's interesting is that congruence criteria have been removed from extended. It's my one slight disappointment there, because I think it's a really good thing to include, and it does involve a lot of problem solving along the way. But also, problem solving has become the dominant concern in most IGCSE syllabuses, and certainly very, very significant for this particular syllabus. You will know that the syllabus has already been moving in that direction, but now the work that we do has to include much more in the way of drawing together different ideas and pulling them together to form coherent logical arguments along the way. So a lot of IGCSE mathematics in the past has been based in taking facts, computing with the facts, and coming up with answers. But of course, we now have to think much more about how we draw not only on facts, but selected tools, computation, and interpretation to give us required results in a much more holistic and full way. So what I want to do today is to look at a little bit of how we can develop that kind of thinking. Now, first up, I would like to talk about this gentleman. This is Barak Rosenshine, and he has performed decades of research centered on something called the principles of instruction. Now, I'm not for a moment suggesting that this is the only way that anybody should teach any topic. But I just want to look at this for a moment because it will give us quite a bit of information about why it is that we can work in the way that we do, and why it is that low stakes assessment actually matters throughout the process of teaching. So Barak Rosenshine initially proposed a very, very large number of different stages in the process of giving instruction. And I'm just going to quickly run through those. You start with a short review at the beginning of the lesson. There are some small steps in practice with limited new material, with clear and detailed explanations. You keep checking for understanding through questioning. There's active practice from the pupils with that understanding. And you're making sure that you're guiding them with lots of examples, lots of modeling along the way. The students get a chance to explain their thinking. You need to check their responses and make sure that you're giving systematic feedback along the way. And then more explanation as needed, more examples as needed, reteaching as necessary, and then preparing them for independent practice at the end of that, and then monitoring that practice. Now, that's quite a long and complicated process, and much of it will just feel reassuringly familiar to everybody. But then actually over time, these have been developed into a much more digestible group of processes. And this is where it starts to feel much more like your usual kind of lesson approach. And what will happen in this is I will focus on 3 of the particular items because they will be the reason for us to look at the idea of low stakes testing along the way. So this shortened version starts with a short review, which will be very important in what I'm about to say. There are some small steps in practice, asking good questions of the students, modeling steps in more complicated problems, and then getting the pupils to actively practice exactly what you've shown them already. Then you need to check their understanding by asking lots of good questions again. And you need to have a high success rate before you move on. And I will talk a little bit more about that in a moment. You're providing scaffolding and support throughout all of these stages, and then gradually move to the idea of independent practice. And then you keep following up with weekly and monthly reviews. Now, 3 of those items are particularly important, and these are the ones I want to focus on today. The short review, the checking for understanding, and the weekly and monthly review. So let's look at what I'm going to get at on these particular elements. Now, just want to highlight at the moment the idea of why knowledge matters. Ed Hirsch, really, really prominent researcher in the United States, has spent decades looking at this very question. In this day and age, we can access a lot of information online. With ChatGPT, you can ask it pretty much anything. I had a long conversation with ChatGPT last night. It felt like I was talking to a real person who was very, very knowledgeable about a lot of things. And it's very interesting because that presents us with this idea that knowledge for the individual pupil is now less important. But E.D. Hirsch actually argues that you need that knowledge in order to understand what it is that you're doing. You can only process understanding and solve much grander problems if you have a really good, strong basis of knowledge behind you. So ultimately, you need knowledge to develop connections between ideas. You need knowledge to form explanations. The knowledge itself promotes critical decision-making because you are drawing on so many different aspects of your thinking. And in short, it is all very, very important for the idea of problem solving. And by problem solving, I'm not talking about doing hard sums, though that may be part of it. I'm not talking about necessarily things that are just in context where you have to extract the information, though again, that can be an example of it. What I'm talking about here is where students spend time thinking about the context of a problem, working through all of the different techniques that they have already learned, all of the different logical processes that they could apply, and then actually bring all of these things to bear on the single problem at hand to form a logical, coherent argument that gets them to the final process. That is really what we've tried to focus on mostly in the new core and extended edition of the textbook that we have. And you will see that we've increased the number of questions that require several topics to be brought together at once. Many times at the ends of chapters, you will see that there are questions that refer right the way back to the beginning of the course. And the idea there is to help us with the review process, checking understanding and making sure that we keep spiraling back to what's going on. So I'm just going to focus a little bit on the short review side of things for a moment and make some suggestions there. This surfaces information that's needed for the lesson, allowing higher order problems to be accessed in the lesson. It's really important that we get to the stage where students approach our lessons wanting to come to them with their knowledge already at the forefront of their minds. This enables them to connect previous learning to new ideas. And this is the beginning of the problem-solving process. And retrieval practice promotes the speed of selective recall and actually helps the students to be discerning about the thinking that they are going into at that particular stage. It is partially the case that short reviews at the beginning of lessons can give you data to collect, but really it's intended to help students learn, and that's got to be the process. It's not a small test at the beginning of a lesson is not to create calm, though it will help with that. It's not for killing time while students arrive, though again, it's going to help with that. But you could use a quick 5 to 10 question test at the beginning based on just facts. And there's nothing wrong with that. What you've got to do is to try to make sure that when you do such a thing, the low stakes are understood by the students and they can actually have fun taking part in this process. What that will do is it will promote the idea of them generating knowledge and keeping knowledge in their heads, which is essential for the problem solving. And I try to demonstrate that to you later on. So simple factual questions are a great start. You need to try to avoid complex problems at the beginnings of lessons, which actually can do more harm than good by putting the students off. It will persuade some students in the room that they are not going to be able to engage with what's coming. So be careful with how you start those lessons. And actually having prizes can work. I remember when I was learning statistics at A-level in deepest, darkest Cornwall here in England, my statistics teacher had a Smarties test at the beginning of every lesson. We had 10 questions on basic knowledge of statistics, and the person who got the highest score won a tube of Smarties. And there was a really lovely thing. It made sure that all of us were engaging with what was going on. It may seem like a cheap trick, but it worked, and it really helped us to keep on top of the knowledge that we needed. But it's got to be fun, because you need total engagement. Otherwise, you're just simply wasting time. So using low stakes testing at the beginnings of lessons can be really very helpful. You can also use this to check understanding. It's a really important element of this. We all know that a common error in teaching is asking students, do you understand? What you really need to do is find out what they understand by asking them to explain, asking them to complete problems, and asking them to engage with what you're doing. You need to probe for genuine understanding, which means students showing what they can't do as well as what they can do, but feeling comfortable with doing that, which is why you need to take the stakes of the testing down. So again, why not use a brief test at the stage of checking understanding for the students? One suggestion that I have, and I'll demonstrate some examples of the kind of thing that you can do with this for really good, useful lesson programming, is using multiple choice. You could explain to the students how multiple choice works and why the wrong answers can be useful discussion points. You could even challenge them to make up their own effective questions and put them to the rest of the class. Now, what you should be doing, this is going back to Rosenshine's research at this stage, you really need to think about trying to get around an 80% success rate. Around about 80% of what's going on has been accessed by the students, and they're able to kind of reproduce about 80% of what's going on. According to Rosenshine, if you can do that, then moving on to the next topic will be a perfectly reasonable thing to do. Now, high stakes testing will actually lead to different approaches for the students and may mask genuine issues that they have, because they will start to over prepare for the tests. They will start to worry too much about the details of them. But low stakes testing can be fun and provides pain-free information to you as a teacher, which will enable the teaching. So I just want to give you a quick example of the kind of thing that you could use when you're checking understanding in a lesson. I know that multiple choice often gets a bad press because it seems like a quick way for the teacher to get information. But actually, if you set the questions up properly, it really does help in terms of kind of developing understanding whilst actually making your time management a lot easier. I saw that that was one of the major concerns that you have. And also in terms of differentiating the classroom as well, which you say is a major concern of yours. Actually, these kinds of questions can make that a lot easier. So take, for example, this circle theorems question. The interesting thing is to think about not just which is the right answer, and I'm sure by now you've worked out which is the right answer, but why the wrong answers actually might have been arrived at, and actually discuss that with the students. You should only ever set multiple choice questions that have those kind of plausible wrong answers in them, and then use them to discuss things afterwards. So if you think about where the 70 degrees comes from, it would appear that that's come from the idea of adding together the B and the 110 in a cyclical quadrilateral, which of course it's not, because one of the vertices lies at the center of the circle. We'll skip the 125, which is a hint about its status in this. The 210 degrees is an interesting one as well, because it appears that one of the angles has been doubled. The student has noted that an angle at the center and the angle at the circumference are related by some kind of doubling or halving process. They just happen to have doubled the wrong number. In the case of the 180 degrees, this student has halved the wrong angle here, because essentially they've assumed that there's a straight line. But the 125, of course, is half of the reflex angle at 0. And the reflex angle is important because it's kind of on the same side as the angle B, and that therefore is the correct answer. And all of those things are really worth discussing. The actual conversation that you will have with the students there will enable them to express themselves about the subject. It will enable them to feel that they've actually achieved something in the test. It will enable them to work out how they can set nice questions for one another. And it's a really important way of thinking about things. Now, coming to the weekly and monthly review, again, testing can be very important here, but the spiral effect of returning to topics with low stakes testing very much enhances connections between topics. And what I would just suggest that you do when you're going to be teaching something new and something that's complicated, take a look at the kind of harder questions at the end of the chapters, the ones that draw together the key topics, and think about the things that students need to know in order to be able to access those. You will then do well to think about using some of those topics as the starters for your lesson. So why not use a brief test on simplifying fractions ahead of a probability lesson, for example? And why not use a brief test on indices before teaching standard form? You could even use sequences to help you with that, where the idea of 10 squared, 10 to the 1, 10 to the 0, 10 to the minus 1, and you can actually work through the whole process of dividing by 10. It's a really nice problem that you can start with. For example, if you know that you're going to be teaching differentiation, one of the major topics that came up in the last syllabus revision, you will notice that there's so much information in this question that could benefit from low stakes testing before. So your possible test topics here could be about sketching quadratics to understand what's going on there. Equations of straight lines would be a really good thing to look at in advance of that. Now, if we look at this question here on proportion, it seems that it's quite a straightforward question on proportion, but again, why not look at shapes of curves ahead of that so that you can bring in the higher order thinking about the graphs and the shapes of the graphs as you work through that. Next up, you could be looking at rearranging formulae. Of course, we usually interrogate the formula that we get from the proportion process in many ways, trying to rearrange it, trying to find different expressions from it. You could do some pre-testing on the algebra related to that. And of course, solving linear equations can come up as something that's a really good thing to review before that. If you spiral back to those topics, it will encourage connections between different topic areas. Now, I do want to talk a little bit about that detail. Ever more important. It's ever more important as well that we're using precise language along the way. Now, this is one of the three things that I wanted to remember here, but I'm only going to mention it very briefly. That said, it's going to be clearly coming up in the next section as well. So this is really leading into the third section of my talk now. The use of mathematical language is ever more important when we need to make connections between topics, because you have to spot how it is that the topics are being referred to one another within the questions. It's so important that you don't allow students to use informal language when they're discussing mathematics. You think about the number of times that you've been looking at angle properties on straight lines, and the students want to talk about Z angles and F angles and X angles. And the problem is that doesn't really tell you anything about the question. It's much better to talk about corresponding angles. It's much better to talk about vertically opposite angles, because there's something that's visually going to be meaningful in the use of those words. And I would really encourage every teacher to think about starting some lessons with discussions about words. It may seem like a really alien thing to do as a mathematician, but it is so vitally important that we're precise. Think about the circle theorems that we require the students to work through. Very, very often, what we need them to do is to explain how they've got their result, and they have to use precise statements of the theorems in question. If we are ever informal in the way that we want the students to give responses to us, or allow the students to give responses to us, they will slip into that and find it very difficult to make the connections that we find later on. And I will aim in the next section to highlight some of those issues. So looking at my final section here on deconstructing problems. This is something that I feel is not actively done a great deal in lessons that I observe, certainly, but I think it should be done more. There seems to be a preference to just give the students really hard questions to do and just hope that they're eventually going to get there through practice, which of course can be really effective for those at the top end, but some just don't know how to start. And I think it's a really good idea for you as a teacher to spend time deconstructing problems with them, using some of the principles as well that we've already spoken about in the previous two sections. So for me, and this is for me personally, and I would urge you to come up with your own sequence of key points here. For me, these are the stages I tend to take my students through when deconstructing problems. But as I say, it's a personal thing. You may well think about things slightly differently, and this is not designed to be definitive in that respect. But essentially, I usually start by identifying keywords within the problem. Trigger words are a common starting point for most people in most subjects, and the students are used to that kind of thing. You then use that to identify in a preliminary way which topics might be important, but of course others may become more important along the way. You try to summarize the main facts using algebraic notation where possible, just to stop having to reread the question over and over again. And then thinking about you starting the process of actually drawing together that information. But of course, in order to do that, you've always got to keep reminding yourself of what the goal is, what you're trying to achieve. I'm going to show you a question in a moment where students tend to forget that they need to remember the original question that they asked with that. And then you need to check the answer's sensible at the end. Now, those simple steps, if you can get something similar to that into the heads of students, they will start to do it themselves. But they need that to be modeled by us. They need to see how it works from the point of view of somebody who's experienced in this area. So go to look at this particular problem, a real favorite of mine. I don't remember which syllabus it was, but back in the early 90s, this was a GCSE question on a national GCSE. And I gather that a very, very small proportion of students actually even attempted it. But it's a wonderful problem for understanding the different stages in how you can deconstruct a problem. So we have two concentric circles with a chord in the larger circle being a tangent to the inner circle, and the chord has length 20 centimeters. What is the area of the annulus enclosed between the two circles? You can immediately see the issue with language here. It's a really important aspect of this. So identifying the important words, For example, circles, obviously, concentric. Do they know what concentric means? Really nice discussion there. Can be broken into two parts, the con and the centric with same center. The idea of a chord, again, do they know the definition of a chord? Do they understand that it joins 2 points on the circumference of the circle and is only a line segment rather than a whole line? There's lots to discuss there. And the circle is a tangent to the inner circle. Do the students understand what tangent means? That it only intersects the inner circle at 1 point. The chord has length 20 centimeters. So length is something that we just put in there because it's going to bring in the idea of lengths within circles, and that's crucial in a moment. And finding the area of the annulus. Do they know the basic formulae for areas? So there's a discussion that you can have just based on the words in that question at the very beginning of it. And that will encourage students to do the same as they work through. So which topics might be important here? At the moment, it looks like it's just circle properties and measurement and area as a specific example of measurement. That's not all, of course. And that's something that we'll come back to in a moment when we look at clues from the past work, how it is that we can use previous ideas that we've learned to help us move forward. So the next thing is to summarize the main facts. And usually a really good way of doing that is to use the diagram. You should always encourage diagram use if you can to summarize problems. So here you'd summarize that you've got the 20 centimeters on the diagram, and you might want to suggest the radii that we don't know of the circles in some way. And it's quite nice to do that in a way that doesn't give away the solution, as I've done here. So next up, looking at clues from past work, you can start to talk about what we know about lengths in circles. Now, they very often involve triangles. They very often involve right angles, especially when there are tangents involved. And it's a really nice opportunity to talk about how we can start to form triangles and right angles using the quantities that we've just tried to summarize. So you might like to get to the stage then of thinking about the distance for half of the length of the chord, and then joining the two radii to make the right angled triangle that is so crucial to solving this problem. Now, of course, that then means that we need to go back to which topics are important, because suddenly it looks very much like Pythagoras might be coming into this as well. And of course, that then gives us a relationship between the two radii, that r squared plus 10 squared is capital R squared. But at that point, the students tend to want to try to solve the equation in some way. Now, of course, we've got two unknown radii here, and that's not possible to do that. At which point you need to remind them, what was the original question? And of course, if you ask the original question, well, what is the area? You can write that down in terms of the capital R and the little r. With a little bit of factorization, remembering these are the clues from the past, you can then get r squared minus r squared, which you can rearrange the original Pythagoras theorem question to formula to give you an answer for. And then you'll realize that it's in fact 10 squared pi, which gives you 100 pi. There's loads in that question that you can work through together. And of course, there's a nice way of checking that it's sensible as well. For example, you could ask the question, well, what if the inner circle in fact had 0 radius? What then happens to this tangent to the inner circle, the chord to the outer circle, which of course becomes a diameter? That raises a whole load of other questions. How then can you find the area of the ring, which is in fact now the larger circle, where you need half of that diameter, which will be 10, and the area of the outer circle will be pi r squared, which is 100 pi. And so, yes, the answer seems to be sensible. Questions like that, if you can find the time to find them and deconstruct them with students, will give you a hugely powerful set of approaches that you can take. Here's another question. It's a little harder here to apply the principles that I have at the top, which is kind of why I've used it, because you do need to modify this each time. So this lovely question goes from being a probability question into being one about quadratics and solving the quadratics, and then understanding the relationship between the two and interpreting the result that we've got. So if you were to identify the important words in here, you've got probability without replacement, and of course you've got some quadratic equations in there, which will tell you which topics you might like to have done some low stakes testing for at the start of the lesson. Some basic probability would be good, but solving quadratics would also be a really nice way to start. You need to have some discussion about what not replacing means and what key elements of learning we've used that principle in the past, i.e. things like tree diagrams and so on. You might like to also focus on these words, the equality of the shapes and sizes, which of course gives you equal probabilities that they are chosen. The idea of what it means for you to have exactly one black and white. If you say that you have one white, that could be one or two in the eyes of some students. But if you talk about exactly, it can be one and nothing else. And the idea of how you show that something is true, remind them of what the process of proof is. There's loads in questions like this, and if you deconstruct them, it gives you so much more that you can use. So beyond that, you'd want to summarize the main facts using probability notation, but the clues from past work there would that you will have been dealing with things like sampling without replacement using tree diagrams, and you could talk to students about that again, and then get them to start using algebraic expressions within that. There's a huge amount in questions like that for you to discuss and get your teeth into with them, but they need to keep remembering what the goal is, which is ultimately to find a probability. And so actually, if they keep reminding themselves that they're finding a probability using a tree diagram, it will naturally be the case that they will then start multiplying along the branches, and it will lead them to a solution much more easily. So ultimately, that is a quick introduction to the idea of deconstructing questions. Now, in the new edition of the IGCSE Cambridge Core and Extended book, we have really revamped the questions at the ends of chapters. The practice questions are hugely increased in both scope and number. And the reason for that is to encourage this kind of behavior, the idea that there are enough questions there for the teachers to be able to use them in deconstruction discussions with students, and for students to be able to use them for testing themselves. We also, of course, emphasize very much the use of keywords, their glossaries and so on within the book, which means that the focus on language is always there. And of course, we provide lots of exam questions in there for the students to really get their teeth into. But low stakes testing is something that the teacher would want to kind of modify for their particular teaching. Another way, of course, of summarizing things before a lesson starts, we have started each of the chapters with an introduction to the kind of things that you need to know in advance. So there are certain prerequisite knowledges that we've made sure that we've put at the beginnings of each of the chapters. So we've tried to support all of this in the new edition of the textbook, which will feel quite different, but still has all of the really good content that it had before, just plus a whole lot more now. But of course, now the good news is that the third edition, which is in line with new syllabus changes, has now been published along with the Cambridge Online Maths. There's an digital version of it available, and the practice books, there are 2 practice books that go with it, are now published too. And you can access all the Cambridge online mathematics from Cambridge Go, and that's all on the slides, should there be anything you need to see there. So that's a quick whistle-stop tour of why low stakes testing matters, why knowledge matters, why language matters, and then how we can deconstruct questions, and then how the resources can support you in doing that. I'm sure that there will be some questions at this stage, and I will do my best to answer those that I can. So thank you very much for listening, and I shall stop sharing now so that we can have a good chat. There we go.
Thank you so much, Nick. That was amazing. We really appreciate this. So now we'll move on to the Q&A session. So if any of you have any questions for Nick, please insert them into the Q&A chat box, and we'll try to answer as many as we can. And I saw some questions about our books. So as Nick just mentioned, and my lovely colleagues mentioned in a chat as well, some new resources have just recently been published. So if you follow the link my colleagues provided, this is where you can find all the new resources. Okay, let's have a look if there are any questions. Not just yet. Okay. Oh, there is an interesting one. Do you have PowerPoints prepared to go along with your book? I guess the answer is no. Is it?
The various online teaching resources have got quite a lot of support material like that, and there are some PowerPoints available to support teachers with those kinds of processes. But what we haven't done is produce PowerPoints that give you lesson by lesson information, because those need to be produced by teachers in a tailored way for their students. I think it's important to say at this stage.
Thank you. There is another one asking, how can we find specimen questions from new topics added?
That's an interesting question in itself, of course. Cambridge themselves produce some specimen questions for these things on their website, and I'm sure that you will have access to that information, which gives you some key resources there. We have, of course, produced some questions for the textbooks and for the practice books along the way. So that gives you those kinds of questions. In terms of actual specimen questions, well, that's down to the exam board, though I will say that using IGCSE questions from across a range of different syllabuses and a range of different past papers and across the board can be useful. For example, when the IGCSE Cambridge introduced differentiation, it had already been used for several years in another syllabus, and so you can actually find questions from that. I'm sure I'm not allowed to say that, but the truth of the matter is that you can get questions from all over. There are various websites that you can go to as well if you want to look for specimen questions on these. Many people have written suggested ones. I can look up some of the links for those and put them into my next blog post if that's helpful, so we can see whether or not we can pull those together. I think that would be a good blog actually, where we can find resources for the new topics.
Yeah, just to let our attendees know that there will be a follow-up blog where we'll try to cover some of the topics we're discussing today, and possibly will not have time to answer today. So there is a question which is more like a clarification. There are QP changes as well, P1 for 100 marks and non-calculator, and P2 for 100 marks and with calculator. Can you confirm that?
So changes in the assessment are something that I'm not really meant to be getting into. That's all set out really very clearly on the Cambridge International website. And I had a look this morning myself. Again, we can provide the links for those kinds of things. But if you go to Google and you just type Cambridge International IGCSE Mathematics, one of the things that comes up as one of the options pretty quickly on Google is changes to the new syllabus. When you click into the website, there's a really nice PDF that comes up about 3 pages long, which sets out how the assessments are changed. I don't have that information right in front of me now, but it's quite easy to get it from the website.
Thank you. I can see a question from Azra. It's asking about the example you gave us today for solving quadratic equations using formula method. Would you advise a student to use a calculator, or to remain the answer as a third?
Sorry, I didn't catch the last part of that. To remain?
The answer as a third.
Do you know what? I think it's really important to explore all of those different possibilities. I really welcome the use of calculators because I believe that they save time and space for the higher order thinking, the actual problem solving. It depends on what the question asks you to give the answer as. If the question asks you to give the answer to 3 significant figures, for example, that is a clue that you probably should use a calculator. But if SERDs are expected, the question would generally say that. And I would advise you as a teacher to vary your requirements on the students and to sometimes say give your answer as a SERD, sometimes say give your answer as a decimal, because the students need to get used to responding to that instruction in the question in the heat of the moment under pressure with that. So my own personal preference is to use SERDs. It always will be because I'm a purist mathematician. I can't help that. But I do understand that sometimes the decimals are just easier to interpret, particularly in physical situations.
Thank you. A question from Sally. How can we as teachers deal with the topics that do not need the calculators as the papers, as progression tests and checkpoint exams?
I always find with non-calculator work, the students they can do it. They're just slightly afraid to because they've lost the crutch of it. And actually what holds them back more than anything is the sense that they don't know whether they've got the answer right or wrong. And I would suggest that time is really good for them to work in pairs and actually spend time doing problems which they can firstly easily do without a calculator and just checking that they understand how to assess one another's work, and then build up to things that they would normally reach to a calculator for. So specific examples of that happening, for example, with combining standard form. So if you're multiplying 2 numbers in standard form together, that's actually something you can do very easily without a calculator if you feel confident with the indices and so on. And actually having a second pair of eyes on that as you work through it is a really healthy thing. So I would advise asking students to set each other questions on it, taking in turns, and then assess each other's outcome. So they've got the safety net of somebody checking their work. Let them use the calculator to check afterwards. There seems to be a myth that when you're doing non-calculator work, the calculators have got to be locked away somewhere. No, I don't think that's true. I think the calculator can help build confidence in non-calculator work in that. So do allow them to use that to check it. But hopefully the example with standard form is one that you can use.
Thank you. A question about revision. How could we complete revising all topics within a span of 1 month before the beginning of mock exams?
Ooh. Well, firstly, I would advise against that, but because I don't think it's for the teacher to actually carry out all of the revision. It may feel that way. I assume that the person asking the question is referring to how we as teachers revise it with them before the mock exams. I would actually probably spend my energies trying to help the students structure their own longer term revision than I would actually going through things myself in an absolutely comprehensive way before a mock exam. Usually before mocks, what I try to do, rather than covering the whole syllabus, is actually get them used to answering more unstructured questions, just to give them time to start selecting tools and recalling things for themselves. That will actually then show them what they know and what they don't know. I think it's far more important they get practice rather than yet more input from the teacher, because you can end up with some kind of cognitive overload if we just pile them with an entire syllabus worth in one month. So really do focus on them doing questions in that month rather than you providing an overview of the syllabus, I would suggest.
Thank you. There is also a question from Ikram asking you for any tip on teaching non-calculator maths.
Non-calculator, did you say?
Yes, indeed.
Yeah, my tip, as I said before, is to actually allow the use of a calculator when teaching non-calculator maths, because they do need the confidence they're getting things right at the beginning. So that would be my top tip. As counterintuitive as it sounds, don't lock calculators away. They're important, and they need to understand that they are getting things right in the first instance.
Thank you. Okay, a lot of questions are coming through.
Okay. I'm probably creating more by answering in ways that people don't agree with. Do you disagree? I'm very happy.
No, all opinions definitely welcome. And
Yeah.
as I mentioned, we'll try to cover as many questions in a blog post as well.
Yeah.
Okay. Okay, there is quite an interesting question. Our school is an event school. We will have too many events in the academic year, and we have to integrate many aspects like Wallace learning, interdisciplinary learning, and many more in our teaching. How do we manage time and complete syllabus with very little time?
So the key to that, and that's a real challenge. I mean, that's something that I hope that you will feel free that you can raise with the leadership within your own school. But if you are faced with that challenge, you really need to get the students used to learning factual information for themselves. And again, this brings back the idea of the low stakes testing. So what you can do is you can set homeworks for them to do and expectations that they learn basic things, and then you can open lessons by testing that they've actually got that knowledge, and then spend the lesson actually developing the problem solving, which is what you really need to spend your time on. Okay, the temptation when you are strapped for time is to plow them full of knowledge and try then to expect them to do the practice at home. I do feel that that's the wrong way round. Now, I don't like the term flipped learning, but if you are in the situation where you are strapped for time, the principles of that are a good way forward, placing the emphasis on the kind of factual knowledge base on the students and the onus on them to learn it. But you have to monitor it, and then you have to make sure that you're challenging it in the classroom. Without that, you may as well just be ploughing them through full of information, which will just overload them.
Thank you. I can see a lot of questions, but we don't have much time.
No.
So let me ask you just 2 more questions. So I can feel the pain here. Many students have developed phobia for maths, even though they know the answers, they're not able to answer confidently. How do we teachers overcome this challenge, and how can we make maths fun for secondary school students? Please help.
Could you just, I've got most of that. Could you just read that one again, please? There's something
Yeah,
really
of course. So many students have developed phobia for maths, and even though they know answers, they lack confidence. So how do we teachers overcome this?
Okay, for a start, if the teacher shows any anxiety around the mathematics themselves, that will contribute to the anxiety of the students, and that's a common issue. That phobia quite often comes from the early stages of their learning, when they are at the kind of the primary age of mathematics, because some of the teachers don't feel confident with it. So firstly, never show a lack of confidence yourself in the actual material. Next, I would say, there's no harm at all in kind of gamifying some of the mathematics, and actually by doing so everybody gets used to failing, and you can only have one winner of a game, for example, which means that everybody together has to go through the process of understanding if you don't quite get something right, it doesn't matter. What you've also got to do is focus, as I said earlier, for example, when I was talking about the multi-choice questions, is focus on how the wrong answers can actually help you to learn. And the reason for us to discuss that is because wrong answers are a crucial component of learning. And so explaining to the students from the outset that if they get something wrong, you and they are going to collectively use that to actually overcome the problem and to overcome their lack of understanding, actually will help them to understand that it's okay to, and they should be making mistakes in lessons. If they don't make any mistakes in lessons, then actually the learning doesn't seem to be happening in the lesson. So you just got to get them into the mindset that that is an important, crucial part of the learning process. And it's what makes it clear to you as a teacher what their needs are. and you can adapt them much better if they show that. So I think that failure culture is very much what you would want to foster, and that's only going to happen if A, you talk to them about it, and B, you then follow through with that and make sure that you're consistently picking up the errors that they make and showing them that they can learn from them.
Thank you. Just the last question. How many past paper revision would you recommend?
As well, as many as you can get. And now the thing is, of course, the syllabus changes are quite small, so there are lots of very relevant past papers. Generally speaking, the first 2 or 3 papers, I think the students should do with their books open. They should interrogate every question in absolute excruciating detail. When they've gone through it and you've marked it and they've only got 95%, those last 5% should be absolutely the focus on it. So I would recommend the first 3 papers you really spend a lot of time on, so they can really interrogate mark schemes, really interrogate how the questions are being asked. And then the next 3 or 4, they can try to do a little bit without their books and then check on it with their textbooks afterwards. And then I would suggest that after another 3 or 4 papers after that, they're generally in a position where they can start to fly on their own. By the time any students have done about 10 past papers, they're usually examination ready, because by that point you will have seen every topic 3 times roughly. Something like that. Some topics obviously come up in every paper, but every topic will have come up somewhere at that point, and they will be familiar with how the questions are asked. So roughly speaking, for my students, it's usually about 10 that they will get to that stage, but that's completely arbitrary, because I think it will just depend on the students you've got in front of you. The main thing is that you are constantly assessing their progress, and that you are constantly responding to that progress and giving them more material if they need it in particular areas.
Thank you so much, Nick. We received a lot of questions about resources and the recording, etc. So I just want to remind everyone that 7 days after the webinar, we'll send you an email with the link to the recording and slides, and you can use that email as proof of your attendance as well. And to find out more about the resources today, we discussed today, please speak either to your sales representative or visit the links my colleagues have been providing in the chat. But don't worry, all these links will be shared with you within 7 days. When the webinar ends, there will be a short survey to complete. It will open on your screens. We'll really appreciate any answers you provide. Nick, thank you so much again. It was really interesting, and I hope a lot of people will find it useful. To everyone who attended today, good luck with your teaching, and goodbye.
Bye-bye.